So the main thing with PA3 was you had to sort of deal with states, right? When somebody hits a plus sign, it can mean a number of different things, right? If they haven't typed in anything, maybe it means ignore it. If they've typed in a number, it means save that number somewhere and get ready to start entering a new number, which means you're going to clear the display next digit. If they've already entered two numbers, maybe that means do an equals and start adding a third number, right? So it's stateful, right? And by and large, this is probably the kind of programming you're going to encounter more often than not as you go further and further is
state machines.
Yeah, state machines, right? And being able to do state machines in software is a really powerful thing to be able to do. So it's good practice. But yeah, I thought the PA3s were great. So really nice work with that. Got the GUIs up and was able to interact with those. Almost all of the uploads were fine. A few people used Java versions other than 8 or 9, and that needed some reworking on my side, but I worked with that anyway. A few people uploaded with some non-standard things like SWT, which is a windowing toolkit, right? And if you do that, there's a good chance I can't run your code. So I left messages in those cases, feedback in those cases. So other than that, though, most of the submissions seemed fine as far as how they were exported and uploaded. So yeah, really good work with that. Do the same level of work on PA4 and you should be getting awesome grades on that too.
I tried to break it so like was not a state machine.
Mm-hmm.
It did not work. So
oh yeah.
I had to like rebuild it.
Okay.
All at once. But I was trying to make it so when you press the buttons, the active listener didn't really do anything. All it did was push the input onto a stack.
Okay.
And then when you would hit equal or any type of evaluation, it would just like bomb it up the stack
right.
and treat it like command line.
Right. And that should be doable.
I think I got it close. I have a version of it saved of the old one, but I think part of it was just like I was really tired and frustrated.
Yeah.
And like I started like my architecture started getting backwards, and I was like, well, if I'm using a stack as a linked list, do I want to keep first? Do I want to keep last?
Right. Right.
Yeah. And it just started to break, so I said, screw it, we're gonna do it the smash my head against an active listener way.
Okay. Yeah, I saw some examples of stack-based machines, which was cool. Some of them would show you the stack on the side so you could see things pushing and popping as you did more operations and operands, and that was cool. So yeah, good stuff. So I put comments on there, which by and large was just, you know, good job or telling you what I liked about your submission and so on. But if there were any issues, I should have comments on there saying where you lost points and stuff. All right, let me hand back your midterms.
I did good.
You did. All right, so let's go over the exam. So I talked about the A version of the test this morning. I'll talk about the B version now. There were some differences between the two exams. So if you took the morning section, you can watch the video for specifics on that. Let's talk about the B exam. All right, so question one, this was constructing a class, right, or writing a class that basically has a couple of constructors, some methods, and the big thing here, so it's a class named My Class contains 3 integers x, y, z. So here's the sort of main confusion that I saw in some cases. So here's class My Class, integer x, y, z. Encapsulation, right, is about putting the data and the code together in a single thing. So we're creating a class. We're going to use this to construct what we call objects. And an object is going to contain some methods, right? A method called init, a method called sum, a method called equal, as well as these integers x, y, z. And the sum method, for example, is supposed to return the sum of x, y, and z. So when we write the method for sum, we're not going to pass it x, y, z, right? That would just be a plain old C-style function. Sum is supposed to be part of an object, right? It's defined in this class, and it returns not just the sum of any x, y, z, the sum of this x, y, z. So when we want to write these methods, we're not going to pass variables to them usually. There may be cases where you're writing a method that wants an outside value. Maybe it's comparing x to some value you give it. But for these, we were just going to use these inside, these variables or these fields that were already designed to be inside here. All right, so we can construct with 3 values x, y, z. So constructor is public, does not return a type, has a name which is the same as the name of the class, and then in this case 3 arguments. And it's as simple as this. So the constructor does take arguments.
Z equals T.
Thank you. Correct. So pass 3 arguments, it assigns those to x, y, z. Now, you could also do this. And if we're thinking of these things as, say, Cartesian coordinates, it kind of makes sense to call the coordinates x, y, z instead of a, b, c, because we never use a, b, c in math for coordinates, right? It's always x, y, z. And in that case, this statement would be something like x equals x, y equals y, z equals z, and those are silly statements because they're just setting x equal to itself. This is where we get into scoping. Since x is defined right here as an argument, there is a value, there is a variable called x that exists within this method, and it refers to this argument. So if we say x equals x, we're setting this argument equal to itself. What we really mean is we want this x up here to be set equal to x.
So
This is where, yeah, this is where we use the keyword this. And this means the variable x that's part of the class itself. Okay, now you could do this dot y equals b. That's not wrong. It's going to work, but it's redundant. There's no need to specify this dot y because there's only one y that has any meaning at this point. That's the class variable y. So you can do this, but it's extra. And so if you don't need it, you can leave that off. Otherwise, you can put this on every single variable that you use inside there, and it's way more stuff that you don't need. All right, so you can make a constructor with a single argument. So maybe just integer a, and then you could just say x equals y equals z equals a. Or you could make 3 assignment statements. And these assignments work. This works in C, this works in Java, right? Z is equal to A and gets assigned all the way over. All right, so the sum method, you didn't have to say public, but I'll say public. It returns an integer. It's called sum. It takes no arguments. And all you got to do here is supposed to return x plus y plus z. Right, just return x plus y plus z. You can say integer value equals x plus y plus z, return value. That works too. If that's clearer to you, if it makes better sense what's going on there, that's a perfectly fine thing to do. But you can do it in one fell swoop also. But if I wanted to do some debugging and maybe print out this value before I return it, right, I might put it in a temporary and then print out that value and then go ahead and return it. That's all fine. And then the init method just sets x, y, z equal to 1, so init doesn't need a return value, so I could declare that void. Still doesn't take any arguments. and so it doesn't return a value. So that's another one-liner. And then equal, which returns true if x, y, and z are all the same value. So this is a Boolean. No arguments. Well, you want to know if x, y, and z are all equal to each other. So it's sufficient to say, is x equal to y and is y equal to z. You could also say, and x is equal to z, but you don't need to do that. If two of these are true, the third is also guaranteed to be true, right? Because equals is a transitive relation. So if x is y and y is z, we know that x is equal to z. Doesn't make it wrong if you have a third one in, but I probably crossed it out and said it was optional. So one way to do this is just like this. Because this is a Boolean, this is a Boolean, the AND of two Booleans is a Boolean, this is a Boolean, and it's going to be true when exactly this is true and false otherwise. So that's a succinct way to do this, but there's other ways. And this almost works, but it'll actually give you compile errors. And I need another brace there, but what's wrong with this?
If x does not equal to y, it doesn't return anything.
Exactly. So this is all one block, and indenting helps you pick these things up, right? This is a block. If we execute this block, we're going to either return true or false. That's fine. But this is the then clause of an if statement. So if this is true, we're going to do this. Otherwise, we're doing nothing. We're just going to fall off the edge of the earth. But we're required to return a Boolean.
The best way to do that is to have a single if statement with the x equals y and y equals z.
Right. So if you do a composite statement, you don't have to worry about this. Or you could go ahead down here and you could say return false. But this, to me, is a bit of a quagmire, right? You get too close on a bad day and you're going to fall in.
Return false is inside the if statement.
Yeah. See what I mean? So that works, right? And it's perfectly fine. The compiler's not going to hate you for it or anything. But think if there's a way that's a little closer to, you know, the intent of what you want. So if x equals y and y equals z, return true, else return false would be closer. This may not seem more logical, or it may, right? But this is fairly clear once you're used to it, right? But even putting this in an if statement to say return true, else return false is better than a bunch of nested, but they all work. So you got to use double equals, not single equals, right? Equal is assignment. This does not work in Java.
I wouldn't imagine it does.
Because x equal y, this is a Boolean being compared to an integer, it's going to complain, right? I should check that, because I said that last time too. It's the most useless Java program ever. All right, yeah, so it's trying to compare a Boolean and an int. All right, anything else on this one? Right, double ampersand is for and, double pipe would be for or. I think that was about it. All right, so question 2, this is setters and getters, accessors and mutators. So the whole idea here is we want to make secret variable and secret variable 2 private inside this class. So let me rewrite this. So secret var 16, secret var 2 is 11. All right, so we're going to change these to secret, right? And we have a main method which is going to do my object mo equals new my object. And it used to say integer x equals my object secret var 2. All right, so I commented this out because this will give a compile error because we don't have access to secret var 2 because secret var 2 is private, right?
But methods inside the class have access.
But methods inside the class have access, and that's the key why we can write a getter, an accessor, because we can write a method in here, we can make the method public, and that method can access this private variable. So let's make a getter, public int, and getters are traditionally called get, followed by the name of the object you're trying to get, and we stick to camel case convention, so even though secret var 2 starts with a lowercase x, typically it would be an uppercase secret var 2. Of course, you can call it whatever you want, and as long as you use it by the same name when you call it, it's going to work fine. But traditionally, this is what it would be called. And then no need for an argument because we're not passing anything. We're saying I want to get back the value of secret var 2, and it's a one-liner, just return secret var 2. So in our main program, instead of integer x equals mo dot, we can say integer x equals mo dot get secret var 2. And then we want to say mo dot secret var equals 2 times x. And again, we don't have access to secret var, so we're going to use a setter. And setters usually take a variable and they assign the value of some internal variable equal to that. There are a few cases where somebody created a setter that took a value and then set x equal to 2 times, or set secret var equal to 2 times that value, right? And that'll let you write this main program, right? But that's not really a standard setter in the traditional sense. Setter should really take blah and then set some variable equal to blah, not 2 times blah. So this is a setter. It doesn't need to return anything. Same thing, set followed by the name of the variable in camel case. Set secret var, but it takes an argument. I'll just call it value, and then it just says secret var equals value. And then to use this, instead of explicitly accessing the secret var variable, we could say my object dot set secret var 2 times x. if we were making a full set of setters and getters, we'd also want to be able to get secret var and set secret var too. You didn't need those for this code. So if you didn't put those in, that was fine. And on the setter, again, traditionally, we would say integer secret var. And then we would say this dot secret var equals secret var. And in Eclipse, when you say build me a setter and a getter, it'll use all of these conventions. All right, so nothing to print anywhere. No output produced by this. No need to assign X to the result of set secret var, because set secret var shouldn't return anything, etc., etc. 2x does not work, 2.x does not work. I didn't take off points for those because the compiler will tell you really quickly, but there's a star in the middle. All right, statics and such, identifying these. So an example of an instance method. So an instance method says we have an instance of a class. We have an object, and we're trying to access a method using the name of that object. And the only place that happens is with ML, which is an object of type mylist. It's an instance of a mylist, and we call ml.search. That's an instance method. So this line right down here. An example of a static method other than main, using a static method, that would be right here, because we don't have the name of an instance, we have the name of the class itself, mylist. That's a class name, and now we're using a method off of that. That's a static. And then object construction, look for the keyword new, that's right here. We're constructing an instance of this object. So constructor you can almost always find by just looking for the keyword new. All right, try catch block. And most people had the right idea here. The main thing I want to say is try to keep your try blocks as small as possible. So integer div, integer x, integer y, integer answer, answer equals x over y, return answer.
The only thing that needs to be caught is division by 0.
The only thing that needs to be caught is division by 0. So really you only need a try catch block right around here. Now if you put your try block, your try statement right here, and you end it right here, you're going to get a compile error. Because if you declare answer inside your try block, it doesn't exist outside of your try block. And you'll get an undefined right here. If you put the whole thing inside a try block, that will work. But that's considered less than good practice, because you're running everything inside this context where you're prepared to catch errors. If you try to put your try block around the whole declaration of the method, that will fail, right? Because a try statement isn't valid outside of a method. So the most succinct way would be try and do this. Now, where you end the try block, up to you. You could go ahead and return from here, but I would probably just end right here. Here's the one thing that might fail. Let's try it, right? And then catch, and exception will work, divide by arithmetic exception will work. Exception is a catch-all. This can be anything that we want, because we're not going to do anything with the exception, but it's got to be there. So what do we do here if there's an exception? Well, the problem says if an exception occurs, return 0. So my inclination would be right here, return a 0. But you could also set answer equal to 0 and then return answer at the end. Either way, so I could just return 0 and then end my catch block. And if I don't go into the catch, I'll just return answer. But if you set answer to 0 and then return answer outside, that works fine too. You don't need a finally block here. Okay, you could use one. You could try answer equals x over y, catch answer equals 0, and then in your finally block you could return. But it's going to come down here anyway. If you don't say finally, it's going to execute what comes after this block regardless. So you don't need a finally, and you definitely don't need an empty finally block. So there are a few cases where someone said finally, curly bracket, closing curly bracket. It's kind of like writing else, bracket, bracket. If you don't need to put something in there, you don't have to say else. If you don't need a finally set of statements, you don't need a finally keyword. So, you know, anything that keeps the code looking simpler is probably good. And don't print anything. Don't say division by 0 detected, returning 0. Because
That's not what they ask.
it's not what they ask. All right, question 5. So use a scanner, read system.in, count the total number of words and the words that begin with an uppercase E or lowercase g, and then print out those counts at the end. All right, so let's see. First of all, there's nothing to print in here until you get to the very end. All right, at the very end of this, you should print out some number, colon, some number, and that's it. Second thing, there's no linked lists anywhere in sight here. A number of people used linked lists. And linked lists are fine. They're fun to write, they're good to have around, but if it doesn't buy you anything, don't complicate your life by using a linked list, right? Use data structures when they make sense. And when a linked list makes sense is really when you're getting information, say one piece at a time, and you need to get all of it before you can do something, right? Like you want to count how many times a word occurs. Well, you don't know the first time you see the word hello how many times it occurs. You have to save that word somewhere so that if you see hello again, you can say, oh, I've seen that once, now I've seen it twice, right? And you can do that with a variety of data structures. If you're trying to put things in a particular order and need to shove things in between, that sort of says linked list, right? If you're just trying to save things in any old order and you don't have to go back and search for them, you can just get away with an array if you know how big a storage space you need. So different data structure for different purposes. But the easiest thing that you can encounter is a situation where you're getting input, and once you get a piece of input, you can deal with it and then throw it away, right? If you have a situation like that, you don't need a lot of sophisticated data structure, and this is exactly that kind of situation. You get your first word, count it, right? Increment your total. Now look at the first character. Is it an E or a G? If it is, increment your special total. And that's it. I never have to look at this word again. I can reuse that variable. I don't need to save it somewhere. So no need for any kind of fancy data structure here for saving things. No need for a word list. A few people created new word lists and actually started rewriting their word list class from PA2. You could make this work like that, but it's really, really putting a lot of extra work on yourself with no real benefit. Same thing, there's no reason to convert things to uppercase or to lowercase or to get rid of special characters. And I found that in some of the submissions here. That was fine for PA2 because that's what we needed to do. There's nothing here about ignoring things that aren't letters and so on. So there's no reason to put that in your code. So you want to use a scanner, right? And there was a hint there when I said use the scanner classes. You want to use a scanner to read from standard in. So something like this. right, which does not have to go in a try-catch block. When you do this on a file, it does. But this won't throw an exception. So that opens the scanner. Okay, so we're trying to read one word at a time, input separated by white space. Scanner has a way to do that. It's called next. When you say scanner object.next paren, it gives you the next word, the next chunk of input separated by a white space. You can do that yourself. You can read an entire line, and you can search for white space, assuming you know that that includes spaces, multiple spaces, tabs, a space followed by two tabs followed by a space, and all these other combinations, right? But Scanner already does that for you, right? This is encapsulation. We've got this class that has all this machinery inside. Let's go ahead and use it. So we do need to know if there is another word. So you want to use the hasNext method to see if there's another word, and if there is, you can read it in by just saying word, and that'll give you the next piece of input, and then go ahead and adjust your totals accordingly. Same thing, you don't want to read one character at a time and try to build up words, right? You can do that, but that's a whole exercise in itself. So probably the canonical way to do this is while sc.hasNext. You can do this with while true, and then inside your loop you can check hasNext, and if it's false you can just return. But same effect, different way that the code will read to somebody, right? Really we want to loop until hasNext is false. So saying while hasNext is true is sort of a direct representation of that intent. Saying while true says I want to loop forever, and then somewhere in there we check this condition and we return if it's false. It's just a little less direct. Doesn't cost you points though. So while sc.hasNext, let's read the word. Let's increment the total. So let's initialize a total equal to 0. And you need to initialize integers in C, in Java, not in C. But in C they're undefined if you don't initialize them. In Java you'll get a compile error if you don't initialize. So we increment the total, and then what we want to do, we want to know if the first letter is an uppercase E or a lowercase g. So here's a direct if statement. Temp character at 0 equals E. So characters we can use equal to compare, right? They're primitives. Or temp.character at 0 equals lowercase g. And so if those are true, increment special. So that's an int. And that's the end of your loop. And then print line. So what do we want? Special plus a colon plus the total. So that goes inside a class, and it has a public static void main, so that it's an actual program.
Why is it unnecessary to do hasNext word? Or
So hasNext means next word, basically. If you want to read a word at a time, it's next and hasNext. If you want to read,
unnecessary.
it doesn't exist actually. It's just the name of the method.
I was looking at Java documentation for my notes.
Okay.
And I saw that on Java docs. HasNext word.
So I don't think there is one. So has next short, has next long, has next line, next int, next float, next double, next byte, next boolean, next big int, big decimal, or has next. But has next is
something different entirely.
has next is doing what you want has next word to do. There may be some other.
Maybe I saw that on the review sheet.
Oh, really?
Maybe.
That would be bad. Could happen.
Pretty sure I saw it as well.
Really?
Maybe next line,
Or scanner in here. Next, next line, next int. And has next. Alright, so maybe it was somewhere else. Alright, so so that's one way to do it, right? You could save temp char at 0 and a character, and then say if character equals E or character equals G, same thing. That would work fine. Here's something that you don't want to do. This looks reasonable, but it's actually got a problem. And it's a little subtle and it's really easy to accidentally do, but what's the problem with this?
I feel like it's a little overcomplicated.
It could be made simpler, but it's kind of cool because we're not using temporary variables.
Aren't you calling next twice?
But we're calling next twice, right? So at first glance, this might look reasonable, but when we call this, we're going to read the next word from our input, and if that doesn't start with an E, we're going to read the word after that and see if that starts with a G. So this is going to really kind of mess up the whole processing. And potentially throw an exception if we have an odd number of words to read, and all kinds of crazy stuff. And it looks really logical, right? So this is one of these 2 a.m. things that can just drive you crazy, because it'll give you all kinds of weird behavior that has nothing to do with the actual issue. So that's something to watch out for. Don't return too early from these kinds of things. Right, our return could be down here, right? If you happen to put your return in here, right, you read exactly one word and then you return. And we don't need a return at all, but sometimes if you do, put it on the wrong side of the bracket and it totally changes the behavior. Always make sure you do has next before you do next. Right, so in some cases code started with a next and then it went into a loop that used has next, but if there's no input at all in the file and you call next without checking has next, you'll throw an exception. So think of them as going together, has next and next. Alright, and then the linked list question. So nobody called me out on this during the exam, but this was totally boneheaded. My idea when I wrote this was we had a linked list class, and it was a linked list made out of my nodes, and the class had one particular my node called header, right? This is the standard setup we've been using all quarter. So header would be either null or the first node of the linked list. But then I asked you to write a method, and for some reason I decided this method would take an argument called my node h, and it's totally ridiculous. I mean, what does that argument even represent, right? So I really should have written this without passing an argument to positive. So some people just ignored the argument and just used header as the first node of the list. Some people ignored header and used H as the first node of the list. So I accepted either of those.
Okay.
And I think this is one of these questions that I wrote, and then I went back to it and decided to make some changes to it. And when I did that, the two versions of it got out of sync with each other. So anyway, we can just run with either one of those. We can just treat H as the header. So you want to count the number of nodes with a data value larger than 0. So you don't want to use dot equals here, right? Dot equals works great with strings. It works great with other objects. You don't need it with integers. We want to go through the list, which means we're going to move through until we get to a node that's pointing to null, right? Where next is equal to null.
Well, the node is not null.
Yeah, and we don't want to look at the data value and stop when the data value is 0. We definitely don't want to stop when the data value is null, right? Those are just mixing different things together that don't belong with one another. So here's a way to do this. So what did we call this? Positive. So Java is passed by value. Somebody asked me that on their exam. It's passed by value, but if we don't want to trust that, we can make a temporary node. Okay, multiple ways you can write the while loop. Let's do a count initialized to 0. While temp is not equal to null. If I do while temp.next is not equal to null, I can get an exception if temp itself is null, right, if our list is empty. So I definitely don't want to start off by checking temp.next. And if I loop until temp.next is null, I'm exiting my loop at the point where I'm looking at the last node. I got to make sure my logic is counting that. And in most cases, when people did temp.next, their counts ended up one less than it should be. It's just an edge case thing, right? Fence post problem. So here's one way to do this. While temp is not equal to null, count that node, and then set temp equal to temp.next.
It requires knowing if the data is greater than 0.
Oh yeah, thank
If
you.
Data is greater than 0. Increment count.
Thank you. If temp data is bigger than 0, increment the count. And then when we're done, just return count. And this was a double data, right? So bigger than 0 means bigger than 0, not bigger than or equal to 1. So that's one way to do it, right? If you initialize the count, if you check to see if temp is null, and if it is, return 0. Otherwise, set your count to 1, and then loop while temp.next is not null. That'll work also. But you got to start your count at 1 or increment it at the very end. No need to do previous nodes here. Some people did temp equals this, previous equals this, and move them along in pair, right? Which we do for linked lists when we're deleting or inserting, but we're not doing anything here except looking at the nodes. Don't need that previous. And if you do that and you realize you never use the value of previous, right? If this wasn't on a test, you could go back and delete those lines because they're just extra. So yeah, while temp is not null as opposed to while temp is not 0, right? C 0 kind of works. Java it doesn't. 0 is not the same as null. All right, so so by and large, really good job on the exam. Details I'm not worried about, right? If you do 1 equal instead of 2 equals, it's like a point or 2, right? I'm not really worried about that. If you feel like you know, you were trying to use a list in question 5 with a scanner and stuff, and you're not sure why, right? My inclination is that maybe if you go back to some of the other code that you did, some like PA2 for example, and try to look at the individual pieces of it, try to understand more thoroughly what a location list is. Write some code that just uses the location list, right? Take the pieces apart and try to really sort of solidify your understanding of each of those pieces. Because if you did the program and you got it working, you know how those pieces go together and work as a whole. But maybe you want to go down and look at those individual elements and try to understand those a little better in isolation. And that might help clarify what's going on in some of these pieces. All right, so tomorrow we're going to spend some time on the board playing around with decision trees and parsing input files and creating input files and also augmenting the trees. Wednesday we'll get back to doing multi-threaded coding, and we'll do that the rest of the week after that. All right, so I will see you tomorrow. Oh, thanks.